Go.
Hello, everyone. This is our submission for the SAS Optimization Challenge 2022. I would like to introduce you to all of my team members, Tamar Laifa, Vidrupa, Rohan, Diego, and myself, Kumar Rahul. The SAS Optimization Challenge presents us with a business case that is a very interesting organizational problem. It presents us with a set of business situations that requires a clear understanding of predictive as well as prescriptive analytics. The understanding of prediction is important when we try to solve for the objective first of the question, and in understanding of optimization method, that is the prescriptive part, is helping us with the objective 2 of the business problem. Working with the SAS tool has helped us understand optimization with code and also have presented us with the opportunity to learn the opt model in SAS. The business case states about a water provision for company XYZ to the building T. Water is required for cooling the building as well as consumption for the employees. There are two different sources of water supply for the building. A company water co, which provides water at two different rates based on a minimum contract. Secondly, a water storage tank belonging to the company, which stores water accumulated from precipitation. The company incurs a charge on the treatment of water before supplying it to the building. To meet the requirements of an environmental certification, the company also requires that at least 25% of the water supplied to the building should be withdrawn from the water tank. The problem presents us to optimize the water supply from water co as well as water tank in such a way that the minimum charges are incurred by the company in the process. To understand the data, we have Tamar Laifa with us.
Okay, thank you, Rahul. We got data from the company that showed the history of the water demand over the years 20 and years 2021. And this graph, as you can see, shows the demand for cooling and main over 2020 and 2021, with month 1 showing March 2020 up until January 2022. As we can see, for both main and cooling, the demand trends are close for 2020 and 2021. And then using this data, we're able to forecast what the next 4 weeks water demand would be. To do this, we had to assess the existing water demand using Excel. We did some data visualization, as you have seen in the previous screen, and we did data forecasting using Excel. This gave us a water demand for week 1 that showed up to 53,244 gallons, and week 4, which shows up to 78,101 gallons. Based on the 2 contracts and the costs and constraints attached to each of the contracts, we calculated the water that will be required from the tank and from the company, while trying to minimize the overall cost for each for the company using both of the contracts. For contract A analysis, we can see that the total treatment costs for the water tank supply comes up to 12,618, and then the total cost for contract A comes up to 35,782,000. On the table, we can see how much water we would use from the tank and how much water we would buy each week, as well as the water storage tank inventory at the end of the week. Using contract B, we did the same thing, and the total cost for contract B came down to 31,149, also showing the amount of water that we would require from the tank and the amount of water we would have to buy at the end of each week. I'm going to move on to Diego, who would show the constraints and some other insights.
In the case of the constraints, we get that we must have at least 30,000 gallons during any week. Also, the minimum percentage of treatment water to be utilized every week is of 25%. Finally, we must buy, at least in the case of the contract IA, 25,000 gallons for 15 cents a gallon, or 35,000 gallons for 12 cents a gallon in the case of contract B. We have to choose one of those options. So when we decide which contract to pick, we pick contract B because it has the lowest cost with $31,149. This has the cheaper per gallon cost and also is the cheapest in total. In case of the optimization results, we get that the water bought per week in the case of week 1 is almost 40,000 gallons. In the case of week 4, it goes to 38,109 gallons. In the case of the water from the storage tank in the week 1 is 13,312 gallons. And in the case of week 4, it goes to 40,000 gallons.
So overall, to summarize the outputs from the analysis that we had, we chose contract B, which costs us around $31,149. On comparing the two contracts, we also see that we have a savings of 4,633 when we choose contract B over contract A. Apart from this, our further analysis has also given us a small insight into how contract 1 and contract 2 have leftover water. That is, after the 4 weeks are done, whether you go with contract 1 or you go with contract 2, you will be having 30,000 gallons in the tank. So this doesn't really turn into a point using which you can differentiate whether you want to go with contract A or B. We choose only the cost based difference. Next slide, please. So yeah, so these are our overall conclusions. So week 1 and week 2, we try to minimize the water usage from the storage tank. Week 3 and week 4, we try to maximize the water usage from storage tank because it is cheaper to do so. And overall, we try to ensure that the minimum tank and contract requirements are met. And by choosing contract B over contract A, we save around $4,633, which is why we choose contract B. So that would be all from our end. Thank you.